All right, this video is going to be about solving polynomial equations, and in college algebra, we keep this just to doing so with greatest common factor and factor by grouping. So there's some reminders here on what polynomial equations are. I'm going to jump right into example 1 here. So when we have a polynomial and we're trying to solve it, we're trying to find the zeros or these solutions. And what we want to make sure that we do is we want to make sure all of the terms are on one side. So I'm going to subtract 80 over to my left-hand side here. And I'm going to factor out a 5 of both of these and an x squared. Now, when I do that, I'm left with an x squared term on this first one, and then I'm left with a 16. 80 divided by 5 is 16. I already pulled out the x squared. And then I can use the zero product property to know that that means that x squared could be 0, and I have zeros. Well, that's only when x equals 0. And x squared minus 16 could be 0, and I will have zeros. You could factor this further. It's a difference of squares, and get x equals plus or minus 4. Or you can use the square root property and know that x must be equal to plus or minus the square root of 16, again giving you plus or minus 4. Our second example does not have a greatest common factor. However, all of the terms are on the left-hand side. So we're going to tackle this one with factor by grouping. I'm going to group this, sorry about that. I'm going to group this like so, with a positive or an addition, a sum in between those two pieces. So I'm going to factor out a greatest common factor here of x squared, and I'm left with x plus 1. And then I'm going to factor out a greatest common factor of the second pair and get a negative 9. When I do that, I see I have an x plus 1 that's a common factor of both of these. And I'm left with x squared minus 9 when I do that. I can factor x squared minus 9 a little bit further since it's a difference of squares. And then I see my 3 zeros that are possible when I have that solution.